video is on integration using residues. In today's video, we are going to solve a problem using residue theorem. So in this video, we are going to evaluate integral z into e power z by z square plus 9 into dz, where c is mod z is equal to 5 by residue theorem. So here, what is given? Integral f of z into dz is given. So clearly our f of z value is nothing but z into e power z by this is z square plus 9. So first of all, in order to find the poles, we have to equate the denominator to 0. So if I equate the denominator to 0, this is z square plus 9 is equal to 0. So this can be written as minus, this is 3i whole square is equal to 0. 3 square is 9, I square is minus 1, minus of minus plus. Therefore, a square minus b square. So this can be written as a plus b into, again this is a minus b is equal to 0. So now if I equate z plus 3i to 0, then see, and next one z minus 3i to 0. So we got z is equal to minus 3i, and next z is equal to plus 3i. So these two are the simple poles. So these two are the simple poles. One is z is equal to minus 3i and the next one is z is equal to plus. So z is equal to plus or minus 3i are simple poles. Now here the circle given here is mod z is equal to 5. Here mod z is equal to 5 is given. For mod z is equal to 5, mod z is equal to 5 can be written as mod z minus 0 is equal to 5. So which means that, so we have to draw a circle. So this is the circle I am showing. This is 1, 2, 3, 4 and 5. Here also this is minus 1, minus 2, minus 3, minus 4 and this value is minus 5. Here if you see, this is I, 2i, minus 2i. This value is minus 3i, minus 4i and this is minus 5i. If you observe this one, this will be I, 2i, 3i, 4i, 5i. This is 5i, 4i, 3i. See here. So with 0 as a center, so with 0 center, so we have to draw a circle with radius 5. So this will be the circle. So this will be the circle. Inside, if you observe this one, minus 3i is here. So this is within the circle and plus 3i is here. So this is also within the circle. So plus 3i and minus 3i are within the circles. So this is z minus 0 is equal to 5 and minus 3i and plus 3i are inside the circle. So we have to find the residues for the given point. So for finding the residues, what we have to do? Residue of f of z at point z is equal to 3i is nothing but limit z tends to 3i. This is z minus 3i into f of z. So now this value will be, this can be written as limit z tends to 3i. This is z minus 3i into f of z. So what is f of z here? This is z into e power z by z square plus 9 can be written as z plus 3i into z minus 3i. So this is z plus 3i into, again this is z minus 3i. So I can cancel this one and substitute 3i in place of z. So this is 3i and this value is 3i plus 3i. And so 3i plus 3i is nothing but 6i. And this can be written as, this is 3i by 6i into e power 3i. So if I cancel in 2 times and see, this will be, therefore residue of f of z at pole value z is equal to 3i is nothing but 1 by 2 times of e power 3i. So this is the residue value for the pole value z is equal to 3i. And next one, if I take pole is equal to minus 3i, see residue of f of z at point z is equal to minus 3i is nothing but limit z tends to minus 3i. This is z plus 3i into f of z. So as you know that f of z value is also ready, that is limit z tends to minus 3i. this is z plus 3i into what is our f of z value. F of z value from the question is z into e power z by this is z plus 3i into this is z minus 3i. If I cancel this one and substitute minus 3i, so in place of z, that is minus 3i e power minus 3i by this is minus 3i into minus 3i. So this is minus 3i by minus 6i into e power minus 3i. So if I cancel, so I got cancelled, and if I cancel minus and 3 in 3 times, that is 3 2 is 6. So this will be 1 by 2 times of e power 3i. So this is nothing but residue of f of z at point z is equal to minus 3i. At the pole value, this is the residue value. So we have to apply, which theorem we have to apply? Residue theorem. By residue theorem, so integral f of z dz is nothing but this is 2 pi I times of this is sum of the residues at interior poles. So the interior poles are plus 3i and minus 3i. So this will be integral f of z. So f of z is nothing but e power z dz by this value is z square plus 9 into dz is nothing but 2 pi I times of interior poles. The first interior pole here is plus 3i, that is half times of e power plus 3i, that is e power 3i by 2. Next one plus this value is e power minus 3i by 2. So this can be written as 2 pi by 2 into e power 3i plus e power minus 3i by 2, and this is nothing but e power 3i by the hyperbolic function. So what is our hyperbolic function here? That is cos hyperbolic function of 3i. So this can be written as 2 pi I into cos 3. So this is again can be written as e power I into cos 3. So this is how we have to solve, and let me explain you. So the problem here is we have to solve this integral f of z dz where c is mod z is equal to 5 using residue theorem. So here I have taken f of z here, and after equating the denominator to 0, I got two poles which are very simple, that is z is equal to minus 3 and z is equal to plus 3. Here the contour is given as the circle mod z is equal to 5, here center 0 and radius 5. So after drawing a circle, so plus 3i and minus 3i are within the circle. So we have to find the residues for each interior pole. For the first pole here is plus 3i. So z minus 3i into f of z, and after substituting in place of z as the 3i, we got e power 3i by 2, and the next pole here is minus 3i. So here in the formula, if I substitute and cancel z plus 3i on the numerator and denominator and substituting z is equal to minus 3i, so we got e power minus 3i by 2. So here according to this residue theorem, we have integral f of z dz is nothing but 2 pi I into sum of the residues at the interior poles. Here these two are the interior poles, and this is the final answer, that is 2 pi I into cos 3. Therefore, this is how we have to solve using residue theorem. Hope you all guys understand. If you really understand, you know what to do. Please subscribe to this channel for more videos, and please practice, and definitely you can score more.